everybody to Material Acts, my solo exhibition. Thank you, Palace. Thank you, the whole team. Thank you so much. I've spent a long time researching geology, and one of the most important geologists in Ireland for me, who's so generous with their knowledge, is Patrick Roycroft. Where I met Patrick was in the Irish Geological Association in Beggars Bush. I went to a lot of those lectures about 15 years ago. And then Patrick is now working in the History Museum, in actually the CRC, which is I keep getting it wrong.
Collections Resource Centre, which just said the National Museum of Ireland.
National Museum of Ireland. So thank you, Patrick, for doing this. I approached him to talk about Irish minerals, basically. Yeah.
Thank you, Kathryn. Yeah, so I'm sort of going to talk about Irish minerals, but with a very strong focus on Kathryn's work. And if anyone wants to email me, that's my email address. Feel free to do so. I'll answer as soon as I possibly can. Yes, I'm at the National Museum of Ireland. I am the one and only curator of geology. It'd be lovely to have another one, but at the moment it's just me. So it's Rocks, Minerals, Fossils, the Works of Ireland. Rare Earth, an exploration of Irish minerals. So we're going to do a bit of exploration of this theme. So to open up, this is a wonderful, colourful mineral which I got from a website called Mindat, which I recommend to everybody. It's a cobalt mineral called erythrite, and it's found in County Kerry. And cobalt and erythrite, I'm just introducing this, a bit of a tease, we'll be coming back to this later. Now, this is not going to be an ordinary talk on minerals, not least because there's a number of slides which are entirely words, which I'll probably mostly read out, but again, that's for recording. If you can't hear, you can read it anyway, and the information is there. So my brief, which was because of Kathryn, was to have a conversation with the Material Acts, which is the exhibition that you're kind of seated within, by artist Kathryn Maguire, who is there, who works with minerals, fossils, rocks, building materials, mining, landscape, to comment on the nature of society's use and understanding of these things, especially in relation to the circular and the green economy. So Kathryn's works, I think, need an element of understanding of various concepts and ideas, and I'm just going to explore some of these, and maybe give some food for thought, and possibly even some inspiration if there's any artists present. I see there might be one or two. So in keeping with Palace Studios and Kathryn's work, this talk's going to be a little bit experimental, not my usual style. We need to deal with the concepts of the titles. So first we must consider what is a mineral. I think that's easy enough to define. Not as easy as all that. It's not as tricky as defining life, which is really tricky. But we are on troubled ground. So a popular definition might be an element or a chemical compound that is normally crystalline and has been formed as a result of geological processes. That already, it sounds good, but when you start picking it apart, it starts to become tricky. Any man-made mineral is not a mineral, by definition. It's a chemical. That opens up a whole range of concepts as to when people make certain substances, maybe say magnetite, or magnetite is coming out of exhaust fumes or whatever, wherever it might come from artificially. It has the composition of magnetite, the mineral, it's iron oxide. It has the structure of magnetite, but because it's not been made by geological processes, you shouldn't actually call it magnetite. You should actually call it a ferrous oxide, believe it or not. But that's very inconvenient. Now, there's a bigger chunk of a definition here. A mineral is a chemical element or compound that has more or less constant composition. So you think, oh, it has to be exact. No, it's within certain bounds and ranges, with allowance for substitutions in specific crystallographic sites. Do not worry about the terminology. It just means that the atoms occur in certain places in particular minerals, and certain things occur in certain places, usually. And you can substitute these. I'm going to play with that a little later. It's often a solid with three-dimensional array of ions and molecules. There are a few exceptions which have been approved, such as some amorphous substances, and the only liquid which is an approved mineral is mercury, which is a very interesting thing. And you may say, approved by who? Approved by the gods of mineralogy nomenclature, the International Mineralogical Association and their various subcommittees. 3, it's formed by natural geological processes and without human, and I've just italicized that, or other biologic intervention. I'm not entirely happy with that, I have to say, personally, because birds, for example, when they navigate, they produce magnetite in the top of their beaks. And this is what they use to detect Earth's magnetic field. But that's a natural production of magnetite. It's not man-made, but it is natural. I would like to include some of these, if you like, bio-minerals as also proper minerals. So I have a little bit of beef with that. Also, a mineral, this should be self-evident, is not a mixture of 2 or more blended substances. It's a single thing. Now, so the details are not important, but the concept of a mineral offers plenty to play with. For example, if we build, I was thinking along these lines, trying to think like an artist, you'd probably go, oh my God. Anyway, here we go. If we build a model of a crystal of graphite, which is pure carbon and occurs in layers, showing the crystal atomic structure, and substitute one of the atoms with, for example, an atom or an apple, or a model human being, such as a Ken or a Barbie doll or something like that, what might artistically we might be saying? So some example answers. I've got 3. 1, we are made of carbon-based chemicals, so this is us. 2, if a model person is placed in the center of graphite, or I got even better, diamond, which is the same chemistry, it's just carbon, but in a different atomic arrangement, could this be a metaphor for being imprisoned in our thinking that life in the universe can only be carbon-based? Could it be silicon-based? Another possibility. We're making the point that we are all of our parts, just chemicals. And if examined under a powerful microscope, remember we're looking at the atomic level here, where is the human soul? Does it exist? Where is it? And so on. So one can play with this kind of thing. So the concept of a mineral is tight, but it's also somewhat fluid. And there's also one can play with that pun if one wants to go down that road. So what about the concept of Ireland as a physical entity? Well, there's Ireland. That's Ireland. Hang on a minute. What happens when we take time into account? Which we must do for minerals, because minerals are formed in the past. When are they formed and why are they formed? We need to understand that as well. So let's have a little whistle-stop look at Ireland through deep time. So we're going back not just thousands of years, we're going back millions of years, tens, hundreds of millions of years. And I'm well aware that there will be many people in the audience who will not be familiar with this concept, which is why I said brace yourselves. So, you know that's Ireland. It's surrounded by sea, it's an island. Right? So, now we've got a series of slides. So, this is Ireland, and we have it labelled Ireland there, during what we term, well, this is geological speak, for the different eras of Earth's history, so the Paleogene period, 23 to 66 million years ago. You can already see that Ireland is not an island. This says continental sea. So this means that all of this is continental land covered in sea, but there's no sense of Ireland anymore, and we're only back a few tens of millions of years. The Ireland that we know and love effectively doesn't exist, even at this, from a geological perspective, early stage. And just have a quick look at India, for example. Even at this time scale, there's still a little bit of sea between India and the Himalayas. The geography of the world is quite different, and it's going to get much more different. The Ireland during the end of the Cretaceous. So the Cretaceous is when the dinosaurs all became extinct. And this is 66 to 143 million years ago. You see that North America is very much closer to Ireland than we are now. The North Atlantic is very much narrower. The South Atlantic is only just beginning. India is down here. It's well into the southern hemisphere. But Ireland, it's connected to this landmass, Eurasia. And it's a very different concept, a very different idea of what we think of as Ireland. Go back further, the Jurassic of Park fame. Time of the dinosaurs, amongst other things. 143 to 201 million years ago. Ireland, nominally here, but we're part at this stage of one gigantic, huge, well, two it says, but really it's a joined continental mass. So it's part of a huge continent, and we are just becoming an anonymous part of a huge continent as we go further back in time. We don't have, unfortunately, in Ireland many Jurassic rocks, and the rocks that we do have in Ireland that are Jurassic are all marine, which is why we don't have dinosaurs in Ireland. We don't have fossil dinosaurs. Which is a great shame for me and kids alike. Wish we did. Now we had them in England. Iguanodon first discovered there, and then North America packed full of them. We're just a damp bit of undersea bit in between the two land masses at the time, so we didn't get anything, unfortunately. Now go back further. The Triassic and the Permian periods, which together 201 to 299 million years ago. Ireland is somewhere in here. We're just, again, an anonymous part of a huge continent, which is called Pangaea. And the world is very, very different back at this stage.
Can I ask a question?
Go on.
Just the lines that you have with the subduction zone, what does
Yes.
that mean?
I wasn't going to get into that.
Okay.
But as you've asked, it just means that where you have ocean crust, there's two types of crust in the world, for argument's sake. Ocean crust, continental crust. Most of the continents are on the continental crust. Most of the oceans are an ocean crust. Ocean crust is heavier, by and large, than continental crust. So when the two meet, they can't really go up, so one has to go down. So the oceanic crust, being heavier, goes underneath the continental crust. And that process is called subduction. And where you have these lines is where you have ocean crust going underneath continental crust. And there's a lot one could say about that, but let's continue on. We're now in the lower Carboniferous. A large chunk of Ireland is underlain by lower Carboniferous rocks. For the most part, again, I generalise slightly, mostly limestone. 323 to 359 million years ago. Many geologists, for argument's sake, say it's about 250 million years because it's an easy number to rattle off and who's going to know. But that's the actual figures. But look at this. Ireland now, it's down here. What's this? This is the equator. We're now south of the equator. Go back in time, we're in the southern hemisphere. We're no longer in the northern hemisphere. go back to the Devonian, which is the period before the Carboniferous. And things start to get interestingly messy. Here we have one of your subduction zones starting to appear in here. And we have Ireland, sort of, it's on the border of a subduction zone and two sort of continental masses. So something complicated is going on at this stage. But we're deep into the southern hemisphere now. I mean, that's the equator up here. So we're now halfway towards the South Pole. Going back into the Silurian, and Ireland is in here, and we have two continental masses. One is called Laurentia, which is effectively modern, you won't be able to see this too well, but it's sort of modern North America. And then there's this little small continent, which is called Avalonia. And Ireland straddles the two. With a little bit of an ocean in here, which is why you've got this bit of subduction going on. Because continents are coming together, and ocean is being forced into the Earth's mantle. Now, that line here, the join between, because I said Ireland straddles the two, between Laurentia and Avalonia, we have it's superficial, but it's a curious thing. And again, from an art perspective, one can play with this. This is Ireland now, as an island. This is Laurentian margin, so this is the old bit of that continent. This is the Avalonian margin down in Wexford. So that's the old bit of Avalonia. In the middle is the rocks, which formed what was called the Iapetus Ocean, so the ocean that was closing. We have a lot of rocks in here. And the join between Laurentia and Avalonia is called the Iapetus Suture. And it goes from Louth down through the Midlands like this and then comes out roughly through Clare, North Kerry. And just by coincidence, the Sinn Féin logo kind of does exactly the same thing. It's just, I'm not the first person to observe this, but it's such a curious thing. And one can play a lot with the idea of, united Ireland, Ireland coming together, Ireland of two halves, etc., etc., etc. There's a lot of, metaphor one can potentially derive from that. Now, this is the final one of these old maps. They're called paleogeographic maps, which is old geography. And this is back in the Ordovician period. We have a lot further, we can go much further back, but yeah, steady on, Patrick. So, Northwest Ireland is here, that's Laurentia, we were attached to North America. Southeast Ireland, Avalonia, that bit of what is now South Wexford, is down here. There's the Iapetus Ocean in between, and we're well into the southern hemisphere. And that's really the concept I want to get across. Ireland, what we think of as Ireland, is only a very, very geologically recent thing. You go back and keep going back, and Ireland becomes a really strange, different place. So, yes, it's another wordy slide. So the concept of Ireland, when deep time is taken into consideration, is mind-bending. For geologists, it's mind-bending. God knows what it's like for people who aren't geologists. And Ireland, and you will notice, let's point out, I have put Ireland always in inverted commas because it's Ireland. It's not Ireland as we know it today. It genuinely does have a split personality. I said dual there, thinking on the way in. It's actually more like triplets because we have the north-west bit, we have the southeast bit, and we have the middle bit. So, and they all have their different personalities. So for the purposes of art and commentary, one could have a lot of modern resonances and political metaphors. So to summarise this one, Ireland changes shape. It becomes an anonymous part of different ancient continents, more than one. It literally moves from one hemisphere to the other. Ireland, when you think of the birth of Ireland, was born in the southern hemisphere. And it was born as twins, because it was one part attached to one continent, another part attached to another continent, and then it came together. So going back far enough, we had two continents crashed together, conjoined, and that adventure of Ireland, during that whole process, we experienced desert conditions twice, one in the southern hemisphere, and then when it drifted north into the northern hemisphere, roughly where the deserts are today. So think of where we are with the Sahara Desert and a bit south of that. Well, Ireland was there as well at one stage. We had tropical seas, so the Carboniferous period. We were on the equator during the Carboniferous. We were in the tropics. Lovely. Apart from some of the nasty marine reptiles which could eat you. We had two periods of mountain building. One from the collision during the Devonian period of Laurentia and Avalonia, because when two continents crash together, you get mountains. You get subduction, you get mountains. We had another one during the Carboniferous period, which we call the Variscan orogeny. And orogeny simply means mountain building period. That's all it means. So all this magnificent history through time and space, moving across the surface of the Earth for hundreds of millions of years, must be understood when then trying to understand why Ireland's minerals developed. We are relating this to minerals. When they developed. And even what minerals likely originated when, and this gets head-wrecking, by relating what rocks were involved in which tectonic processes when. All of these things need that. You're not expected to, this is just to blow your minds. You're not expected to truly grasp this. It is pretty deep. So this has a direct bearing on what minerals we might expect to discover, possibly to exploit, possibly not, which impacts directly on modern society. And really all I'm trying to say there is that what happened hundreds of millions of years ago in the past directly affects us now. And artists and geologists can play with this quite a lot. Now, rare earth, remember that was in the title. So this has a modern scientific meaning and an ancient meaning, and we can explore a little bit of both. So the rare earth elements, which is a scientific term with a precise chemical basis, are a group of elements that form a special group within the periodic table. Most of you remember that from school days. And now I'm going to attempt to name these ones. Lanthanum, cerium, praseodymium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. And we also have scandium and yttrium, often get included, but they're not technically rare earth elements. Nowadays, and this is again, we're focusing, coming in a big arc back to Kathryn's work, we also talk of critical elements, which is a much more imprecise term, and is actually based on man's technological needs rather than anything, strictly speaking, scientific or natural. So these elements include lithium, cobalt, scandium, gallium, indium, etc., and the rare earths. And we can add to some of these precious metals of silver, gold, platinum, and palladium, and I couldn't resist this one, which is named after the mythical Greek god, sea nymph and warrior Pallas, which gave rise to... So the earth is an ancient Greek term for elemental compounds that couldn't be further broken down by fire. So we can, with a little bit of flexibility, use the term for minerals generally and can start a conversation around interesting and perhaps more locally Irish minerals. So rare minerals, where they're found, why they're formed, when they're formed, what they're used for, as well as what they're used for scientific wonder, which is my prime interest, but also technological applications, which one simply cannot ignore. So many of the above named rare earth elements are unfamiliar, and I'm guessing most of you will not have known most of those. Would that be a fair statement? And yet, they're absolutely crucial to the quality of life that we enjoy today. Society needs them. even if you've never heard of them, we use them all the time. If you've got a smartphone, it's full of this stuff. For example, some products that contain rare earth elements. So iPods. This is a bit of a crummy slide from the USGS, but anyway, it makes the point. iPods, dysprosium, neodymium, praseodymium, samarium, terbium. Without these weird and wacky elements, you wouldn't have an iPod. Fibre optics, erbium, europium, terbium, yttrium. Your fluorescent light bulbs, europium, terbium, and yttrium. Wind turbines, which are, burgeoning all over the place. Dysprosium, neodymium, praseodymium, particularly neodymium. There's very, very powerful neodymium magnets in wind turbines, which are the things which, if you don't have them, you won't get the electricity generated. So we absolutely need neodymium. And I suppose another point might be that although this is related to green in the concept of not carbon polluting, but not in the sense of, well, this stuff just comes out of nowhere. This stuff comes from somewhere. So if we want green energy to have computers, or to have smartphones, green cars, to communicate with rapid, fibre optics, to have satellites for the internet, then we need rare earth elements, and we need the precious metals, and we need things like lithium. And this is important. All stuff has to come from somewhere. No matter what it is, if it's made of matter, it has to come from somewhere. And if you've got it, if you're wearing it, this room, this computer, this old style camera in my pocket, this is all made of stuff. It has to come from somewhere. It doesn't just materialise. And there's a saying, if it doesn't grow, it has to be mined. And that's kind of a profound thing when you really start thinking about it. Where does that material originally come from? The implications are profound for how we as a society react to things such as mines and quarries. Without mines and quarries at the base of the manufacturing chain, modern life would be impossible, wouldn't exist. And I'm going to go there. One can include oil as well, because it was something that was pointed out to me. I hadn't thought about it until someone said it, and I went, oh my God. But where do roads come from? You look at your car, you look at the road, where does that come from?
Bitumen.
Bitumens, which come from oil. Which comes from oil. Without oil, you wouldn't have roads. And the rock in the road has to come from a quarry. It has to be quarried. So do we want life-saving surgical stents, which have oil-based materials in them, plastics and so on? So I think the summary is one point that I would like to make is burning oil and coal is an atrocious waste of a phenomenal, and really when you start looking at it, near miraculous natural resource. And just burning it is a horrendous thing to do, as well as being dangerous to the planet and our own health, global warming and the implications of that. Wasting plastic is appalling, but plastic itself is a wonderful thing when used right, and has many, again, like surgical stents. There's lots of good uses for plastic. Not all plastic, by no means is all plastic bad, but wasting it, making stuff we don't need out of it, that's bad. So all this amazing material, along with lots of minerals, the foundation of modern society, and without oil, we'd still be living in the 1850s. I don't think anybody actually wants to go back and actually live in the 1850s. So we need it. The problem with oil is burning it. That's the problem with oil. So all this could be further explored now through art, which Kathryn Maguire has done, and has potential consequences for Ireland. So let's explore some art.
Thanks.
This is one of Kathryn's pieces. It's called To the Mountain. And it is made from a limestone taken from a mountainside quarry owned and run by D.K. Trotter & Sons in County Leitrim. And you can't read this, but it says, the symbol is of a trig point found on mountains and sites of elevation on a map.
It's also carboniferous limestone.
Oh, wait, I'm getting there. You're preempting me, Kathryn. So, this is, I got this just off the internet, so concrete, this is the quarry, if I'm not mistaken. And the quarry itself is used to produce concrete. So, questions start to arise. Do we want quarries in the landscape? Do we want more homes built during the housing crisis? Where does concrete and cement come from anyway? Well, there, amongst others. But there's a curious irony here when relating Kathryn's art piece to the mountain, which has the trigonometric point marked on it. And as I said, trig points are used to precise location and for elevation above sea level. But if we consider the rock that was carved on and where it came from, we're dealing with Carboniferous period limestones. During the Carboniferous, Ireland was on the equator or a bit south of it, so your exact location has a whole other new meaning to it. And elevation above sea level? I think not. We were below sea level in tropical seas. So we're in a different place, in a completely different environment, underwater, not up a mountain in Leitrim. So that trig point has different, for me, as a geologist looking at it, has a number of different meanings and potential ironies. Now this is called underground potential, and it's a piece that you can see, Kathryn has it over beyond, and in it, this inspired me to go off on one really, because in it she says there's a West Cork mine extracted in 1810 by the slavery of women and children. Technically, slavery might be putting it a bit harsh, but it was just about on the verge of slavery. And I remember reading some time ago for a lecture, another lecture I was doing on mining in Ireland and genealogical sources for this, reading about the conditions that miners suffered when dealing with copper mines and so on. And so I took the liberty say someone needs to do an art piece titled Starvation in Hell, because that was the life and the death of many Irish miners, particularly in Waterford and Kerry. And the thing is, again, we don't think about this, but they suffered broken bones, and there was no medical treatment whatsoever. Broken bones, severe malnutrition, bleeding and wounds, lethal poisoning. People did die from drinking the metal-laden mine waters because it was the only source of water that they had available. They didn't have bottles of water or stuff, they didn't go down with that. It was like puddles of metal-infested sludge, and they were drinking that. And it was hot down the mines. And exhaustion leading to falling to one's death, getting out of the mine at the end of a shift. Because when you got to the end of the shift, you actually have to physically climb out of the mine on slippery, wet wooden beams, and you'd be exhausted from being down there for God knows how many hours, and you could just literally collapse, slip, and fall to your death. And then, if you managed to make it home, you were living in horrendous living conditions. Some people were actually living within sand dunes, and they would, their house, i.e. their hole in the ground, would sometimes get completely flooded out with sea spume if there was a storm. And it was absolute total misery. The workhouse was literally better, and the workhouse was bad, but it was better than this. Thankfully, modern Irish mines, such as Navan zinc mines, are a model of excellence in both conditions and pay, and we can all be actually very proud of Navan zinc mine. This is another artwork by Kathryn, which is also over yonder. Mineral Mountains. It's modelled on Iron Mountain in County Leitrim, respectively impregnated with, you can correct me, it is gold, shungite and iron oxides.
Mica.
Mica as well in there, yes, for the gold one. And again, it prompted me to think, okay, how might this affect us in reality? So the holy mountain of Crowpatrick in Mayo is the only place in Ireland that we currently know of where you can find in situ bedrock gold. Gold that we find elsewhere, you either can't see it, you can't physically see it, or you find it as grains in river deposits. But here at Crowpatrick, it's actually in the quartzite bedrock. And there is enough gold to make it worth mining. But no government that I can think of is going to let this happen, although legally they could. And that's a thought. But again, this is just opening the conversation. We want our computers, our mobile phones, our cars, our satellites, our air travel navigation, and we need gold to make them. Well, are we going to be all NIMBYs, not in my backyard, about mining? It has to be mined somewhere, it has to be mined where the gold is. You can't say, well, mine is in Leitrim, but there isn't gold in Leitrim. So when resources get scarce on Earth, and I'm going a bit more general here, and ultimately they will we allow gold mining in Crowpatrick?
I don't think so.
Well, not in our lifetime, no.
Have you climbed Crowpatrick?
Oh yes,
recently?
oh I know it.
There's enough
But I'm saying
to stop it.
Well look, are we putting off the inevitable, even if this is decades or centuries away? I'm just putting this out there for debate. I'm not advocating one thing or another. I'm saying if you want gold for your things, gold has to come from somewhere. What are we as a society going to decide on where that gold comes from? That's all I'm saying. So, not one of your pieces, Kathryn. Chalk them on. So, it's a brick with Nor written on it. So, brick, often handmade, used to symbolise here shelters often needed, unfortunately, but thankfully, for women to be safe. Now, brick itself is made mostly from clay minerals, so the clay must be found in the landscape. But consider this. Where are the clays coming from that are being used, and that will be needed to be used in large quantities to make bricks for modern homes? And again, coming back to the housing crisis, perhaps. The old brickwork quarries during the 18th and 19th centuries, which were all over Dublin, now just pinpointing Dublin here, everywhere. But places like Rathmines, Rathgar, Crumlin, these are all built over. We can't get at these anymore. So again, there's an irony which we can extract from this. The more land that is used for housing, the more land that becomes unavailable to access the raw materials needed to make the houses. Or that could be used for agriculture to feed the people in the houses. How might the situation ultimately end? And what do we as a society want to do about that? And these are things that not just geologists, but this is what I'm saying, artists as well. These are big questions that need to be addressed. So, when it comes to Irish minerals, what exploration might we do? I'm going to briefly look at two things of interest. One, Ireland as a repository of critical elements in the widest sense, and Ireland as a host to rare or undiscovered minerals. Lithium, this slide all relates to lithium. This is a map, Dublin is here, that Howth is here, Killiney is here, Wexford, part of Avalonia, is down here. The Wicklow Mountains are in here, that's Carlow, Blackstairs Mountains are here. Lithium is vital for modern batteries, environmentally friendly cars, heat-resistant glass, certain industrial lubricants, and some antidepressant medicines such as Prozac. That's what lithium is used for. Southeast Ireland actually has resources of lithium and it is actively being prospected. In fact, it's been prospected for decades. We're just going through a current round of modern prospecting. And although this is stream sediments, this is showing roughly where the lithium is. So this is actual, now the rock in which lithium occurs is a rock called pegmatite. a coarse-grained rock associated with granite. The lithium, it's these long white crystals here.
Just over there.
And just over there. I won't try and point to it, but bottom right. Which is from
Killiney Hill.
Which is from Killiney. And this is stream sediments, not bedrock, but this is showing where the lithium is concentrated. So there's a lot down here, not up here. Although you'll notice that there's nothing here. That's because bedrock hasn't been marked, but actually there is lithium up here in and around Bono and Enya's house and all that sort of area. Is there going to be a mine there? I doubt it. The rocks in which lithium is found also host minerals that contain elements, that again, critical elements, rare earth elements, tantalum, which is used in electronics, so there's tantalum capacitors in computers. There's a thing called niobium, which again we briefly mentioned, which is used in magnetic resonance imaging machines in hospitals. So these things are phenomenally useful for modern technological purposes and modern society and modern life. Also, niobium is used in high-strength steel. But the question remains, how do we get these elements out of the ground in a way that is acceptable to society? And spodumene, which is the lithium ore, which is these crystals, we actually have quite a bit of spodumene, a little bit really up here. There's no danger of Bono being mined out of his house. But we do have quite a bit of spodumene down in Carlow. And that is potentially mineable. So, as far as I know, however, Ireland does not have that many critical element minerals of interest. However, we do have mineable gold in several localities, including a proposed partially opened gold mine at Curracanault in the Sperrin Mountains in County Tyrone. Which is there. And as noted earlier, we have cultural and religious icons such as Croagh Patrick. So do we want to mine Croagh Patrick? Do we want to mine a beauty spot in the Sperrins? Well, irony abounds also in Irish geology if you go looking for it. So if you remember Kathryn Maguire's unwittingly perhaps ironic, I don't know if you've actually considered the geological irony of it, but to the mountain, well, the gold at Curracanault has both irony and a pun which you can possibly play with. The irony is that the gold here is microscopic, so you can't see it with the naked eye, but it occurs as minute grains within very easily seen mineral pyrite. Pyrite is known as fool's gold. But in this case, you'd be fooled into thinking there was no gold because you weren't going to be fooled by the pyrite, when in fact there was actually gold in the pyrite, so you've been doubly fooled. And the pun is that the pyrite is the mineral iron sulfide, meaning you can relate back to the irony by being ironic. It's stretching it, but I enjoy these things. And you can play with this stuff, and you can go, you can do things. So a cunning artistic use could be made. Ireland, not many people yet really appreciate this, but Ireland also has platinum in County Wicklow, Aughrim and Tinahely. And platinum is used in medical devices, catalytic converters, electronics. Again, it's a vital metal in modern society. And very recently, I think only in 2023, the mineral bastnasite cerium was found in the Mourne Mountains, and it's associated with the mineral monazite cerium. Now these minerals, as it says in the actual name, which is in bold there, contain cerium, which is used in light-emitting diodes, again, more high-tech stuff that we use. And also in these minerals, we have the elements lanthanum and neodymium, which, I hope you will recall, are used extensively in modern society, such as wind turbines and green energy production. So what about the erythrite? We have the erythrite, we went at the very start. This contains the element cobalt. This is also used in lithium-ion batteries, which we use now a lot of the time. The green economy, high-strength alloys. But this occurs in the lakes of Killarney. rocks around the lakes of Killarney. Are we going to go mining there? And there was copper there as well. Are we going to resurrect that as a copper deposit? Final tranche. What of Ireland's potential as a wonderland for rare minerals, mineral forms, or minerals new to science? So I think Ireland has huge potential because relatively few people, compared to many countries around the world, amateur or professional, are engaged in finding or researching Ireland's mineral heritage. Historically, Ireland has, I think it's for many reasons, a whole lecture unto itself, not been that well explored as other countries. And it's something that I'm working on to try and rectify that. And I'm going to give you a few examples to end the talk on. This is the world's largest hopper garnet. What does that mean? Garnet is a type of mineral. It's actually a family of minerals. It's often used in jewellery, amongst other things. Hopper refers to the shape of the crystal faces in that they're kind of like that. And you can see that here, the edges and points are higher than the centre, which was called, that's a sort of hopper shape. And this is from Donegal. And I was doing, I was asking a few other geologists about this, because I spotted that this was a hopper garnet, and it's a very unusual thing. And I sent a message out to a variety of colleagues. And this, by the way, the size of this, there's no scale on this. This is as big as my fist, so bigger, slightly bigger. So it's 7 centimetres across. It's a big thing. The nearest comparable hopper garnet in the world is, I think, 2 millimetres. So this is a monster. And it's from Ireland, from Donegal. We also have, potentially, some spectacular beryl crystals from the Mourne Mountains. I say this is spectacular and contentious, and allegedly from the Mournes, because it's yet to be absolutely proven. There is some debate over whether these genuinely come from the Mourne Mountains or whether they come from Siberia. Won't go into all that debate. It's a long and complicated and interesting one, but you know, if you're going to be optimistic, the Mourne Mountains had historic beryl specimens that look something like those. And again, those are, I won't raise my finger at you, but they are about as long as my middle finger. So again, that's big, and that's gemmy quality. Silver. We have native silver from Glendasan in Wicklow. This is a very rare 19th century specimen, and this is the silver here, and also this grey stuff is the silver, but these are crystals of silver, which look like sort of little pigtails, if you will. And as far as I know, and I stand to be corrected, there may only be 3, maybe 4 surviving specimens of Wicklow native silver left in the world. Most of it was smelted down. Very few specimens actually survived. This, when I came across this, which was a part of the old UCD geology collections, now with the National Museum of Ireland, this is native silver from Ballycorus, which I didn't know about. And I've never seen another specimen comparable. I think this may be, again, open to ratification, this may be unique, but there was native silver in Ballycorus. But you look at that, if you go wandering around in the rain in Ballycorus and you see some grey stuff, would you recognise that as silver? Keep your eyes peeled. This is a big beauty. This is a very large, deep purple with red flashes. Red flashes are sort of coming in there. And this is amethyst. But not from where most people think amethyst comes from. This is from Blackrock in County Cork.
That's where I was born.
Ha! 19th century specimen, not well known even to Cork people. They know a lot. The original 19th century quarry, I found out, is now a car park. So, do other specimens, do they lie just beneath the car park? Who knows? But this is spectacular stuff. One of my favourites, Cotterite, the world's rarest form of quartz. Quartz is one of the commonest minerals on the Earth's continental crust, but it occurs in dozens of different forms, and the rarest of them all is Cotterite because it has this shiny, pearly, metallic lustre. Normal quartz looks sort of glassy. Looks like bottle glass, in effect. But this, just on the surface, looks like it's been spray painted with aluminium. And it was only ever found once on Earth in 1875 in Rock Forest in County Cork. Never again by a Grace Elizabeth Cotter, named after her. And I have a YouTube video on that if you'd like to watch it. But that is, again, the rarest form of quartz on Earth. It's in Rock Forest in County Cork. What it was. So to start to draw all these strands together, everything I've been talking about so far, it's about concepts and conversations. So conversations between geologists and artists, conversations within society about how we navigate and balance the need for raw materials with the need not to devastate the land and the sea and the wildlife. And when one thinks more about the concept of a mineral, the concept of Ireland as an ever-changing physical entity through time, the concept of place that is not as stable when you consider long time spans, the concept of rare, the concept of irony in Irish geology, there are so many avenues now that are potential for artistic exploration, and avenues which Kathryn Maguire is exploring actively, thank goodness, causing us to think more about what we live on, what we need from it, what our needs mean for the evolution of Ireland as a human inhabited country, because it's for us, and human society in general. So, I took this from your website, so I hope it's correct, Kathryn. You urge us to become more environmentally aware and socially engaged about what we need and where all our material, all our stuff, comes from and how we get it via mines, wells, quarries, and so on. Stuff does not just come out of nowhere. But how do we deal with the consequences of that reality? And where, in an ever-increasing need by humanity, coupled with an ever-increasing population, is this ultimately going to end? Big question. But let's be positive. So, for minerals as purely wonderful objects, Ireland holds huge potential for more discoveries. I'm lucky in finding a few. I spotted a few that I'm just showing you. And I think we stand on the threshold of a great deal more. So finally, thank you all for coming to my talk. Thank you to Kathryn Maguire.
Thank you.
And I will end by just a comment on this, which is a wonderful thing. This is a zoned muscovite mica from Dublin granites. The extraordinary colourful growth feature, which was first described, as far as I can tell from research in the literature, in the late 19th century from Dublin, nowhere else. And it occurs in but I found that it occurs in muscovite worldwide, not just Dublin. This is everywhere. And it is very common. And yet, it is almost unknown. Most professional geologists, never mind the public, are completely oblivious that this exists and is right under their noses.
So what size is that?
That's about 3 centimetres across, diagonally. So that's big. Now you do need to see it under a special way with 2 bits of Polaroid plastic, but very, very simple, very straightforward, and should be on t-shirts. So, thank you very much.